Imagine this. You're staring down a massive code base refactor.
Oh yeah, the kind of thing that takes forever.
Exactly. Days, maybe weeks for a senior dev, right? But instead, you give it to an AI agent, one prompt, and, well, it just re-architects the whole application.
That's the picture Google's painting, isn't it, with this Gemini Code Assist agent mode?
It is. But here's the kicker. The thing maybe they're not shouting about so loudly. New research, pretty solid stuff, suggests these AI tools might actually make experienced developers, get this, 19% slower.
Slower, wow. And there's more, right?
Oh, yeah. And potentially lead to a 41% increase in bugs. 41%.
Okay, so today we're diving deep into that. Google's big play here, this really surprising research that kind of questions the whole narrative, and why this matters so much for, well, for software development right now.
Welcome to the deep dive.
Yeah.
Yeah, what we're looking at today, it's not just another fancy tool. It feels like it's hitting at something more fundamental about programming itself.
Absolutely.
Yeah.
And this whole AI coding assistant market, it's just exploding.
Totally. The numbers are wild, like $25.9 million this year, projected to hit almost $98 million by 2030.
That's what, nearly 25% growth every single year. Huge. And everyone wants in.
And Google's agent mode feels like the biggest shot fired so far in this coding assistant war.
It really does. Because it's not just, finishing your line of code. They're pitching it as an AI that can plan and actually execute these really complex changes across multiple files, whole code bases.
And are being super aggressive with the offering, aren't they?
Extremely. Giving developers 180,000 free code completions a month. That's 90 times GitHub Copilot's 2,000.
90 times. Plus the chat messages, too.
Yeah, 240 chat messages daily. Copilot gives you 50 a month. It's a massive difference.
It's definitely a statement. So I've got to ask you, our listener, are you using AI coding tools currently? And maybe more importantly, how does it affect your confidence? Do you feel more confident in your code quality or perhaps a little less? Keep that thought handy.
Yeah, because the research we're about to dig into might change how you think about that.
Okay, let's unpack what Google actually built here. Because agent mode, it really does feel like a step change. Not just better code completion, but something different. Autonomous programming, maybe.
That's exactly the term they're leaning into. And it's a crucial difference. Your typical AI coder, like Copilot, works very locally, line by line, suggests a little snippet here, fixes a typo there.
Right, good for boilerplate, maybe small functions.
Exactly. But Google's agent mode is positioned as this AI pair programmer. It's designed to look at your entire project, understand it, and then plan and carry out these big multi-file jobs from just one high-level instruction.
And the examples they showed were pretty impressive, weren't they?
They really were. Things like update all the API endpoints to use the new authentication method across, potentially dozens of files.
Or add a completely new full-stack user settings page, like from scratch, front-end, back-end, the whole deal.
Yeah, and even stuff like update this core library and fix all the breaking changes. Which, any developer knows that can be an absolute nightmare. Days, sometimes weeks, of just painstaking dependency chasing.
The scope is just, it's huge. It's not about auto-completing a few lines. This is architectural level stuff. Things a senior dev would normally spend serious time planning and executing.
And what makes that possible, technically speaking, is what Google's calling comprehensive project understanding, powered by this massive 1 million token context window.
1 million tokens. That's the biggest out there, right?
By far. Think of tokens like the AI's working memory. 1 million tokens means agent mode can essentially hold your entire application, or a very large chunk of it, in its head at once. It can see the connections, the architecture, your specific style.
Whereas Copilot and others are more limited.
Much more limited. Usually just the current file, maybe a few related snippets. So this isn't just like a bigger memory chip. It allows agent mode to grasp the global context in a way others just can't.
It makes me think about this monster refactor I did last quarter. Took me a solid week, touching, 50 files.
Oh yeah, I know the feeling.
The idea of just telling an AI, do this, and it happens, it sounds amazing. But then you see the research we're about to discuss, and you start to wonder, is it maybe a bit too amazing?
Right. Is there a catch?
Okay, so here's where it gets really interesting and maybe a little confusing. Google's pushing agent mode for productivity, obviously. But some really recent solid research paints a very different picture, and seems to depend massively on who you are as a developer.
Yeah, let's start with the studies that seem to back up the AI hype. You've got work from MIT, Princeton, UPenn, They looked at about 4,800 developers using GitHub Copilot.
And what did they find? More speed.
They did. On average, those devs completed 26% more tasks, and they saw a 13.5% increase in actual code commits. So on the surface, that looks like a pretty clear productivity win.
Okay, 26% more tasks done. Sounds great. Case closed. AI makes us faster.
Well, not so fast, because then you look at other research and things get complicated.
Oh.
There's this 2025 study by METR. They're a well-respected AI research group. They found something startlingly different. When they focused specifically on experienced developers...
Good seniors.
Yeah, exactly. Those using AI tools actually took 19% longer to complete their tasks compared to experienced devs not using AI.
Wait, longer? 19% longer, not faster?
Longer. The AI actually slowed them down.
Okay, how does that even work? How can one study show a big speed boost and another show people getting slower?
It seems to boil down almost entirely to experience level. The data across multiple studies shows this really stark divide. Junior developers, they see big gains, like 21% to 40% faster.
Wow, okay, so it helps newbies get up to speed.
Significantly. But senior developers, their gains are much smaller, maybe 7% to 16%. And like that METR study showed, they can even end up being slower overall.
Okay, so the benefit shrinks dramatically with experience and can even reverse. But what about the quality of the code? Does faster mean better?
That's the other really critical piece, because a study by UpLevel, they looked at 800 devs, found basically no significant overall productivity improvements when you factor everything in. But what they did find was alarming. A 41% increase in bugs introduced into the code base when AI tools were being used.
41% more bugs.
Yikes, indeed. And then you have GitClear. They analyzed a massive data set, 153 million lines of changed code, and found patterns they're calling AI-induced technical debt.
AI debt, what does that look like?
Things like increased code churn, meaning code gets rewritten more often, more copy-pasting of patterns instead of proper abstraction, and just generally lower scores for code maintainability.
So it raises some tough questions, doesn't it? Like, if you're a senior developer, are you willing to potentially be 19% slower just for the, I don't know, the convenience of AI?
Or if you're running a team, do you accept 41% more bugs hitting your code base just to get tasks ticked off 26% faster? These are the real trade-offs developers and managers are starting to grapple with right now.
Let's dig into that quality issue a bit more because, yeah, that feels like the really crucial part for a lot of teams. This AI debt idea from GitClear, based on analyzing millions of lines of code, it sounds serious.
It is potentially very serious. They're seeing concrete patterns. Code churn is up, suggesting the initial AI-generated code often needs more follow-up work. There's measurably more copy-paste programming happening.
Which we all know leads to maintenance headaches down the line.
Exactly. And actual code maintainability scores are dropping. Plus, debugging seems to be getting more complex overall when AI assists heavily.
You know, I played around with some of these tools, and I think I've felt what they're describing. The code often works, like it passes the tests initially, but sometimes it just feels, I don't know, brittle, or maybe just not very elegant.
Yeah, functionally correct, but lacking that deeper architectural thought, that foresight about how it fits into the bigger picture.
Right.
And that seems to be the core issue. These AI tools are amazing at local optimization, solving the specific, immediate problem right in front of them, often very efficiently.
Makes sense.
But they struggle with global optimization, thinking about the whole system. How does this new piece interact with everything else? Does it duplicate logic that already exists somewhere else, just slightly differently? Does it follow our team's established patterns?
So the AI might write a perfect little function, but it doesn't realize it's the fifth, slightly different version of that same logic scattered across the code base.
Precisely. Or it uses a pattern that clashes with the rest of the module. It optimizes the trees, but misses the forest, you could say.
Okay, so could this lead to, like, AI-generated spaghetti code on a large scale, even if each strand of spaghetti looks okay up close?
That's the risk. And it creates this huge dilemma for engineering managers, doesn't it? Do you chase the faster feature delivery that AI seems to promise, knowing you might be racking up technical debt much, much faster?
How do you even measure that long-term cost against a short-term speed bump? It's tricky.
It's very tricky. And that 41% bug increase. What's really worrying is that these often aren't obvious syntax errors. They tend to be subtle logic errors.
The hard kind to find.
Exactly. The kind that slip through code review because the code looks plausible. Imagine Agent Mode refactoring your authentication system in, say, an hour instead of a week. Seems great. But what if it introduces a subtle vulnerability that nobody catches for 6 months?
Oof, yeah. That's the nightmare scenario. The hidden cost.
That's the potential dark side, yeah.
So, thinking about your own work, maybe for our listener too,
Yeah.
have you personally noticed these kinds of quality differences? AI code versus human code. What sort of patterns jump out, if any? It's really valuable to hear those real-world takes.
It is. These studies give us data, but individual experience adds that crucial context.
Okay, now let's tackle the elephant in the room. What does all this mean for actual software developers, for careers?
Because the implications here, they feel pretty significant.
They really do. If AI tools mostly help junior devs get faster, but might actually slow down seniors, that kind of upends the whole traditional career path, doesn't it?
Well, you're already hearing talk from industry folks. Companies leaning hard on AI assistance might start thinking, do we need as many junior developers? Do we need as many interns? Maybe even fewer product managers if the AI can handle some of that routine spec-to-code work.
Right, if the AI handles the easy stuff, why hire humans for it?
Exactly. But then you hit this huge paradox.
Which is?
If you hire fewer juniors, how do you grow the seniors? The very people who, according to some of this research, are potentially better off without the AI or at least need to use it very differently and critically. You could accidentally create this massive skills gap down the road.
Cutting off the pipeline to create the experienced people you still need, that's a paradox.
It really is. And it throws up big questions for computer science education, too. Should universities be teaching students to use these AI tools from day one, or should they double down on the fundamentals, algorithms, data structures, architecture, so grads can actually understand and critique what the AI produces?
It feels like you need both, right? You need the fundamentals to even know if the AI's output is any good, or how to fix it. But you also need to know how to actually work with these tools effectively.
I think that's probably right. It's not an either-or. You need deep fundamentals and the ability to collaborate intelligently with AI.
And from the company side, the business side, the appeal is obvious.
Oh, absolutely. If Google's Agent Mode can genuinely handle a massive, complex refactor that would normally tie up 3 senior engineers for a month, the cost savings are potentially enormous.
But the flip side is those engineers aren't getting that critical experience doing that refactor themselves. They're not learning and growing in the same way.
Precisely. Though it's worth remembering, something like 57% of developers are already using AI in their workflows. This isn't some far-off future. It's happening now.
So the race is on to figure out the best way to use it.
Yeah, the companies and the developers who nail that human-AI collaboration, leveraging the AI's strengths while mitigating its weaknesses, they're going to have a huge advantage.
So looking ahead, what are the possible ways this plays out?
You can sort of sketch out maybe 3 broad scenarios. 1, AI gets so good that most coding becomes AI-assisted. Humans are mainly reviewers, architects, prompt engineers.
After the AI-dominant future.
2, we see a split. Maybe you have AI-assisted teams focused purely on rapid development, getting features out fast, maybe accepting some AI debt, and then separate teams doing high assurance, AI-free, or AI minimal development for critical systems where quality and rigor are paramount.
A 2-track system. Interesting.
And the third possibility, maybe the quality issues, the AI debt, the subtle bugs, maybe they become so problematic that the industry collectively takes a step back. AI tools remain useful, but firmly in a supplementary role, not driving the process.
So AI dominance, a specialized split, or a cautious pullback. Which one do you think is most likely, and maybe more importantly for everyone listening? How are you preparing your own skills, your own career, for whichever future unfolds? That feels like the key question now.
It really does. It's moved from theoretical discussion to active career planning.
All right, let's try and make this practical. We've talked about the potential, the pitfalls, the paradoxes. If you're listening to this, whether you're a dev on the ground, a team lead, or running engineering for a whole company, how should you actually navigate this? What do you do about agent mode and these tools?
Okay, first, for individual developers, I think step 1 is honest self-assessment. Where are you on the experience spectrum? Because the research strongly suggests AI tools will affect you differently based on that.
So if you're junior.
If you're junior, line in. These tools genuinely seem to accelerate learning and boost productivity early on. Use them, learn from them, get faster.
But if you're senior.
If you're senior, be a little more skeptical maybe. Don't just assume AI will automatically make you faster at everything. Focus its power, use it for the tedious stuff, the boilerplate, the repetitive tasks. But guard your time and energy for the complex architectural thinking, the deep problem solving, the stuff where human insight still seems crucial, and where AI might even slow you down if you're not careful.
Okay, that makes sense. What about for engineering teams? How should managers approach this?
The big message from the research seems to be proceed with caution and a strong process. Don't just throw AI tools at your team and hope for the best. Implement them gradually. And critically, double down on your code review processes.
Because of the 41% bug increase finding.
Exactly. That doesn't have to be your reality if you build in safeguards. Maybe consider having all significant AI-generated code go through an extra, more rigorous review cycle, especially if it touches critical parts of the system.
What kind of specific safeguards should teams think about putting in place?
Things like mandatory human review, absolutely non-negotiable for anything non-trivial generated by AI. Really robust automated testing suites that must pass for any AI-assisted changes. Maybe even clear labeling within the code base. This block was AI-generated, this was human-written, so you know where to look closer later.
Tracking AI debt, too.
Definitely. Regular technical debt assessments, specifically looking for those patterns, get clear identified churn, copy-paste, low maintainability. And monitoring performance are the AI-assisted workflows actually faster and better in the long run for your specific context.
Makes sense. And then zooming out. For the whole organization, what's the advice for, say, a CTO?
I'd say resist the urge to make a sudden, sweeping decision based purely on vendor promises of productivity boosts. The reality is much more nuanced.
So don't just mandate everyone uses AI for everything.
Probably not the best approach right now. Instead, be strategic. Identify the tasks where AI genuinely offers a strong advantage with manageable risk. Things like generating initial drafts, handling boilerplate code, maybe doing routine, well-understood refactoring tasks. Let AI handle those.
And keep humans in charge of the tricky stuff.
Keep human oversight firmly in place for complex system architecture, critical business logic, security implementations areas where subtle errors have big consequences.
So maybe Google's Agent Mode is perfect for that big, non-critical legacy system refactor you've been putting off.
Could be. That might be a fantastic use case with a great risk-reward profile.
But maybe not for rewriting your core payment processing engine from scratch just yet.
Exactly. Be selective. Match the tool's capability and risk profile to the specific task.
So the overall takeaway seems to be experiment. Yes, these tools are powerful, but measure everything.
Measure everything. Productivity, yes, but also code quality, bug introduction rates, long-term maintainability. Because the research shows context matters hugely. What works brilliantly for one team or task might be detrimental for another. You need your own data.
So wrapping this up, the AI coding revolution, it's not science fiction anymore, it's here. Google's Agent Mode is definitely pushing the boundaries, showing us a glimpse of potentially autonomous programming.
It really is cutting-edge stuff, but all this research we've looked at is such a vital reality check. Just because something is revolutionary doesn't automatically mean it's better in every situation or without significant trade-offs.
Yeah, it feels like the future isn't about choosing humans or AI. It's about figuring out that smart collaboration.
Exactly. The developers and the teams who master that integration, leveraging AI's power while consciously maintaining human critical thinking, architectural skill, and quality control, they're the ones who are going to thrive.
It's about finding that optimal blend. Well, thanks for joining us for this deep dive. It's certainly given me a lot to think about.
Me too. It's a fascinating, fast-moving space.
And maybe here's a final thought to leave you with, something to mull over. What happens when these AI agents start writing their own tests?